Hi, everyone. Welcome to the DrSquirrel session. I hope you all are having a great time attending this year's Flink Forward. Definitely a lot of great talks with focus on different areas. And our talk today will focus on a specific topic, which is the Flink job diagnosis and troubleshooting. So if you code with Flink, there is little chance you can bypass this problem. So I hope we can share some insights and experience that you will find helpful from this session. Cool. So let's get it started. My name is Fan Shu. I am an engineer working at the stream processing platform team at Pinterest, and I have my teammate Lu Niu with me today to co-present DrSquirrel, which is the self-serve diagnosis tool that we built to create an easier and faster experience for Flink job troubleshooting. So during this session, I will start off giving an overview of our team, the platform, what use cases we support. I will then explain the challenges we had when driving the adoption of Flink at Pinterest and how the adoption is greatly affected by those pain points in troubleshooting that we eventually decided to build a tool to solve it. After that, I will give it to my coworker Lou to talk about how we designed the features of DrSquirrel with a walkthrough of highlight features, then its architecture. We will end with our future work and the Q&A session. So our team is called Stream Processing Platform Team, and our goal is to build a scalable and a reliable platform that engineers at Pinterest can easily develop, test, debug, deploy, and manage their Flink jobs. Basically, we want to make each step of the Flink job lifecycle easy, no hassle for our engineers. There are many use cases currently running on our platform. So when you open Pinterest and see different pins, some Flink jobs are running to compute real-time machine learning signals for a customized user experience. Some jobs are there to reduce unsafe content as close to content creation time as possible, and all that to make sure we provide a nice experience for our users. For the advertisers, we use Flink jobs to calculate the ad spending against their budget in real time and update them with more timely reporting. For our creators, Flink is also used to surface engagement metrics. Say you post a pizza recipe. With these real-time metrics, you will be able to refine your content with minimal feedback delay. So as you can see, these use cases really bring great value to a broad audience of the business. To support a smooth and a reliable onboarding of all those Flink use cases, our team has built various components in the platform. For example, at the development time, engineers have the option to choose between raw Flink and NRTG, which is a framework that allows you to write Flink jobs faster with fewer lines of code without writing any Flink boilerplates. And my coworker Divya Kapoor is presenting RTG this year as well. So please go check out his talk or recording later if you are interested. Besides that, at the development time, we also provide a common library, such as unified source connector to help build the job more easily. And we have the job management service to handle the deployment with monitoring of the job status. It also handles auto restart and AZ failover. The CI/CD pipeline keeps running on each merge master, so it's faster and easier to track which commits could introduce errors. We also have Statsboard and Elasticsearch set up for metrics and log monitoring. So DrSquirrel is like the latest component we built for the health check and the debugging purpose. So, and that is our topic today. At the very beginning of our platform, where we didn't have all those components, we actually got a lot of feedback and questions from our customers. And the most typical ones are these. For example, people would say, oh, hey, there's just big chunk of my code is boilerplate, but I just want to focus on writing my business logic, ideally with some simple APIs that require little tuning for the job to be stable. So we just built the RTG framework to address this request and increase the dev velocity. And as we support more use cases, engineers are merging commits more frequently. At the same time, we were working on many platform improvements. So when an issue happened, it was unclear if it came from a platform change or a job change. So we built the CI/CD pipeline to test and monitor each commit. However, as you can see, some remaining questions couldn't be solved. For example, the massive pool of metrics and the logs are not easy to make sense of. And when the log says, oh, there is a lost task manager, what does that really mean? It could be caused by a bad node, a hardware problem, some network issue. It could be out of memory that brings down the young container. So for someone who just starts coding with Flink, how could they figure out that, right? And how to fix it? So these questions are all troubleshooting related that kept growing and growing with more use cases, and our support load was increasing significantly. So this is what motivated us to build a tool, which is DrSquirrel, to address these type of problems. To design a tool for troubleshooting, we first analyze what exactly caused the troubleshooting experience to be difficult. So first, there are too many UIs and stats. We used to check three places: stats board, Flink web UI, and Yarn or Elasticsearch for logs. Engineers need to check dozens of job or server metric dashboards, click through the job nodes in the Flink web UI, scroll through a wall of logs in Yarn, not to mention that if you want to track those sets of historical runs of the job and make a comparison, that's way more hassle. Besides the constant jumping between these UIs, we also realized that actually 90% of these stats we spend time on searching and verifying are either benign or simply unrelated to the root cause. So we were thinking, why can't we pick out the problematic metrics and logs and show them in one place directly? Second, we notice when people find some bad job symptoms, the solution is not obvious right away. In fact, Flink troubleshooting needs multiple stages of reasoning from identify what metrics and logs are problematic to analyze them for the root cause and eventually find a solution for it. So this requires engineers to have a solid Flink knowledge way beyond just data stream APIs. For example, a checkpoint timeout is a very common issue. It could be caused by insufficient timeout config, of course, but could also be a result of back pressure, slow S3 upload, bad GC, data skew, etc. So this made us wonder, what if we just analyze the symptoms programmatically and give a solution right there without having people do the reasoning on their own, and just they don't need to go through these stages. The third thing is that the troubleshooting doc didn't work very well as we scale. So on the left side, it's actually a small portion of our troubleshooting doc. It was quickly getting too long to search for a specific issue with all the stack traces and the diagnosis steps we put there. The doc also became very difficult even for us to maintain. We could accidentally add redundant content to it and make it even longer and harder to search. Besides that, people have to manually apply the if-else diagnosis logic, which still involves lots of metric checking, which actually has a lot of room for automation. Lastly, the doc also has instructions to make the job comply to some platform requirements, like best practice. And the doc is not great at call to action, especially for preventive purpose, because people tend to check the doc only when the issue really happens. So all these pain points made us decide to build a tool for it. the goal is ambitious. We want to reduce the number of the UIs engineers use from many to one for their troubleshooting, cut down their troubleshooting time from hours to minutes, and lower the required Flink knowledge for debugging from intermediate to little. So to achieve all these goals, we've designed the features that center around these three areas. So it should be a one-stop shop with fast issue detection and issue fixing suggestions. I will now pass to Lou, my coworker, to give a walkthrough of the features and take it from there.
Thanks, Fanshu, for the introduction. Hey, everyone, I'm Lou. I'm software engineer at Pinterest. I will work through the features DrSquirrel provided and also talk about the architecture. So DrSquirrel will be is a one-stop shop for Flink job health and troubleshooting. Metrics, logs, and configs are all in one place. It's easy for users to check. It is also a more organized way to view logs and metrics. It can group historical runs based on job names, so it's easy to view changes across multiple runs in history. It is also helpful to detect issues. It performs several health checks, including back pressure, checkpoint, memory, CPU, data skill, etc. And it shows pass-fail status of each health check. It also shows restart courses and provide aggregate view. All the job states showing in DrSquirrel are persistent. So we can also query those data in query engines like Presto or Hive. Last but not least, DrSquirrel also provides suggestions for restart exceptions and issues like back pressure. Next, we will briefly walk through those features. Next slide, please. When you open the tool, you start with searching your job name. Then you will see a list of the current and all historical runs in a single page. It provides details like job state, start and end time, cost estimate, and running cluster. Next, please. In job detail page, we show 5 tabs for each job run. We expect user to simple switch between the tabs to get a full picture of the job health and self-serve for debugging. The 5 tabs are overview, shows IDs, launch time, last checkpoint stats, number of fully restart, etc. And also next tab is restart courses, shows exceptions directly leading to job fully restart. And also we provide suggestions on how to fix it. Next, we also show health checks. It shows pass and fail on important metrics. Exceptions are a way to view error and warning logs. The last one is configuration. We show all the job configurations along with Flink configurations and system configurations. As I mentioned before, DrSquirrel provides a more efficient way to view logs. User can switch between timeline view and unique exception view, as was showing in the screenshot. Under timeline view, we order all the exceptions based on time, and we show exception test along with a log search link. The user, there's a search bar, and user can also easily search and find the interested logs. Next page. Under unique exception view, we group all the exceptions and show first, last, and total occurrence of logs. User can also sort by occurrence to find the log they are interested. Next slide, please. We provide action items for users if it's a known issue. For example, here we suggest users to increase the sync parallelism under these exceptions thrown from Kafka sync. In this way, user don't need to ask in Slack, and our team's troubleshooting load is reduced. Next. We provide lots of health checks, including back pressure, throughput, memory, CPU, data skew, etc. In this GIF, you can see user can easily view job health and how to fix issues and how to tune their resource usage. Here you can see we show task memory usage, job manager memory usage, the CPU usage, actual CPU usage of each container, and whether there's a data skew. And we also show the GC related information. There are a bunch of checks. Yeah, we also show back pressures. We list the back pressure status and the suggestion how to fix this issue. Next page, please. We also show job configs and make it searchable in UI. Sometimes config can be hard to track by just checking configuration file, because user can always override configuration values through command line parameters. Searching configurations here ensures we are always looking at the final values. This also reduces troubleshooting time. For example, with no domain knowledge of any Flink job, I can easily do a simple search and find out what's the input and output Kafka topics and what's the external service the Flink job calls, along with other important parameters. Also, as I mentioned before, all the job states can be queryable in query engines like Presto and Hive. Therefore, I can do a global search of all the job configurations, for example, to find out all the jobs calling a specific Kafka cluster to know who will be potentially impacted if that cluster starts migration. Next slide, please. In the last part of the talk, I'm going to talk a little about the architecture of DrSquirrel. It consists of two components: the Flink job watcher and the DrSquirrel server. The Flink job watcher, we actually built out several Flink components like metrics reporter, Kafka log4j appender, so that all the running jobs, they can emit metric and log data to Kafka. Flink job watcher is a Flink job. It listens to both metric and log Kafka topic and aggregate those data by job ID. It builds a full job snapshot and then emit the data to Kafka. Next slide, please. Then the second component is DrSquirrel server. The server is stateless. It listens to corresponding Kafka topics and present the job snapshot data in the UI. It also pulls dashboard and Yarn resource manager for more data like job resource usage, external dependency metrics, etc. Next page, please. So right now, DrSquirrel is fully in production. We are monitoring 100% of the jobs running in testing and production clusters. We reduce issue detection time from hours to less than 5 minutes. Almost about 90% of the common issues can be detected. And we also reduce our team's troubleshooting supporting load by 50%. Next page, please. Yes. Here are some items in our future roadmap. First, we want to integrate with external service house. If a job talks to external service, DrSquirrel can automatically expose service house in the same page. In this way, we can easily be notified when external service has issues. We also want to integrate with CI/CD. DrSquirrel can provide job health data in this CI/CD pipeline, so we can block a problematic diff if it leads to job unhealthy. We also want to provide weekly health summary report so users can know their job health after job goes into production. Enabling alerts and notification is another item. So users don't need to come to the web page every time. Last but not least, we want to explore auto-tuning in DrSquirrel, and it contains the complete health status of Flink job. Next slide, please. We published an Eng blog about DrSquirrel, and also there are some other great blogs about streaming processing at Pinterest. Feel free to check them out. That's all about DrSquirrel. Thanks for joining.